Titan is a crime scene. For decades, we called it a frozen moon. We put it in textbooks as a footnote, a hazy orange ball orbiting Saturn, interesting mostly for having an atmosphere at all. Most people stopped paying attention after that. They figured the story was simple. A cold, dead world too far from the sun to matter. That is the version of Titan most people still carry in their heads, and almost none of it is true. Because while we were treating it as a footnote, Titan was busy being one of the most chemically active, geologically dynamic worlds we've ever encountered. And when the Huygens probe finally landed on its surface, what it found didn't just surprise scientists, it broke their models. Titan orbits Saturn at an average distance of about 1.2 billion kilometers from the Sun, roughly 9.5 times farther out than Earth. At that distance, sunlight is about 100 times dimmer than what we feel on a summer afternoon. The temperature at the surface sits around negative 179 degrees Celsius, cold enough to freeze water solid as rock. For decades, every model said the same thing. At that temperature, with a moon this size, roughly 5,150 kilometers across, larger than the planet Mercury, Titan should be geologically simple. A frozen ball of ice and rock with a strange, hazy atmosphere. Nothing more. That was the consensus going into 2005. The Huygens probe, released by the Cassini spacecraft, descended through Titan's atmosphere on January 14, 2005, after a 7-year journey. It took 2.5 hours to fall through the thick orange haze, then continued broadcasting from the surface for over an hour before its batteries died. Piece by piece, the old version of Titan fell apart. The first thing that stopped scientists cold was the atmosphere itself. Titan is the only moon in the solar system with a substantial atmosphere, thicker than Earth's, composed mostly of nitrogen with traces of methane. The surface pressure is about 1.5 times what we experience at sea level, on a body with far less gravity holding it down. That alone was strange because an atmosphere that thick on a moon that small meant something was actively replenishing it. Methane should be destroyed by sunlight within about 10 to 100 million years, broken apart into heavier hydrocarbons that rain down to the surface. Yet methane is still there, abundant, which means something underground keeps resupplying it. When the radar images came back from Cassini, the surface turned out to be carved by something nobody expected. Rivers, lakes, seas, not of water, but of liquid methane and ethane, pooling across the northern hemisphere in formations that looked eerily like Earth's coastlines, complete with inlets, channels, and drainage basins carved by flowing liquid. Kraken Mare, the largest of these seas, stretches over 1,000 kilometers across and may be hundreds of meters deep in places. Titan is the only other body in the solar system, besides Earth, known to have stable liquid on its surface today. Just not the liquid anyone expected. Titan appears to have a methane cycle that mirrors Earth's water cycle almost exactly. Methane evaporates from the seas, rises into the atmosphere, forms clouds and falls back down as rain, carving river channels on its way back to the basins. Cassini documented storm clouds forming and dissipating, and Huygens photographed dry riverbeds and rounded stones during its descent, shaped not by water but by methane flowing for who knows how long. I want you to sit with that. An entire alternate hydrological cycle, running on hydrocarbons, at temperatures that would instantly kill anything we understand as life, operating quietly in the dark for millions of years. The secrets don't stop at the surface. Gravity measurements taken during multiple Cassini flybys revealed something unexpected. Titan's icy shell appears to flex in response to Saturn's pull in a way solid ice simply cannot do. The deformation only makes sense if there's a layer of liquid water beneath the surface, a global subsurface ocean, likely mixed with ammonia acting as antifreeze, kept liquid by tidal heating from Saturn's gravity and residual heat from Titan's formation. That ocean is believed to sit roughly 100 kilometers beneath the icy crust, possibly in contact with a rocky core below. If Titan's ocean has a rocky floor with even modest hydrothermal activity, you have the same basic ingredients that support life in Earth's deepest oceans: liquid water, mineral-rich rock, and an energy source, sealed away in total darkness beneath kilometers of frozen surface. Nobody is claiming there's life on Titan. But the fact that we can't rule it out, on a moon this far from the sun, tells you how badly we misjudge this world. Then there's the surface chemistry. The orange haze that gives Titan its color comes from tholins, complex organic molecules formed when ultraviolet light breaks apart methane and nitrogen high above the surface. These fragments recombine into longer carbon-based chains that drift down and coat the surface in reddish-brown organic sediment, layers of prebiotic chemistry accumulating for billions of years. Titan is sitting on an enormous, untouched laboratory of organic chemistry, 4 billion years in the making. Cassini's radar also revealed vast fields of linear dunes near Titan's equator, some stretching hundreds of kilometers long, composed not of sand, but of solid hydrocarbon grains shaped by Titan's surprisingly active winds. These dune fields cover roughly 17% of Titan's surface, an entire desert built from chemistry that has no equivalent anywhere else we've explored. Now take all of that. The methane rivers, the hydrocarbon seas, the underground ocean, the organic haze, the dune fields, and add one more thing. Titan appears to have cryovolcanism as well. Several features in Cassini's imagery, including a mountain informally called Doom Mons, show characteristics consistent with ice volcanoes, vents that may have once erupted with a slushy mixture of water, ammonia, and methane rather than molten rock. What gets me is the scale of the revision. Before Cassini and Huygens, Titan fit neatly into a simple narrative. Distant, cold, hazy, interesting mostly for having weather at all. Every part of that undersold it. It has liquid seas larger than some of Earth's lakes. It has an active hydrological cycle running on hydrocarbons instead of water. It likely has a global ocean hidden beneath its ice. It has organic chemistry accumulating in quantities found nowhere else in the solar system. There is already serious momentum toward going back. NASA's Dragonfly mission, a nuclear-powered rotorcraft about the size of a small car, is scheduled to launch in the late 2020s and arrive at Titan in the mid-2030s. Unlike Huygens, which had one shot at one location, Dragonfly will fly from site to site across Titan's surface, sampling different terrains and searching for any biosignatures that might indicate Titan's chemistry has crossed the line from prebiotic to something more. Consider what a single probe and one orbiting spacecraft revealed in just over a decade of close study. A world we thought we understood turned out to be one of the most dynamic, chemically rich places in the solar system. Rivers of liquid gas, seas you could sail boats on if the cold didn't kill you first, an ocean buried in darkness, organic snow drifting down for eons, and dunes built from chemistry humanity has never touched. Titan doesn't care how long we ignored it. It's out there right now, 1.2 billion kilometers away, raining methane onto rivers that have been flowing since before complex life existed on Earth. And the most unsettling part isn't any single discovery. It's the pattern. Every time we've sent a spacecraft to something cold and distant that we assumed would be simple, it turned out to be extraordinary. Enceladus, Pluto, and now Titan, which means every other icy moon we haven't studied closely yet could be hiding the same kind of complexity. We've barely scratched the surface of the outer solar system, and the surface is already more alive than we ever imagined. Thanks for watching, and I'll see you in the next one.